All right, let's try another one. So for the function given by f of x equals x squared minus 1, find the limit as h approaches 0 of f of 3 plus h minus f of 3 over h. So again, just finding the slope. So the first thing I'm going to suggest we do is figure out what in the world f of 3 is. So f of 3, let's plug in 3, we got 3 squared minus 1. That's 9 minus 1, which gives us 8. Okay, we can plug that in a second. So the limit as h approaches 0 of, and let me color code this, so we got f of 3 plus h, that's going to mean we're plugging in 3 plus h instead of x, so it's going to be 3 plus h squared minus 1. That's that whole group. Then we're going to have minus f of 3, we already got was 8, so that's our blue group there. All that divided by, let's just do h in green. Now, that first group is going to be same deal as last time. We have 3 plus h squared, so it's going to have to be 3 plus h times 3 plus h. I'm also just going to get rid of the brackets because at this point it's not going to make a difference. So we're going to have 3 plus h times 3 plus h. Still have that minus 1 and still have that minus 8. We'll take care of those in a little bit. All over h still. Now let's go through and distribute that red group. So we got 3 times 3, which is 9. 3 times h is 3h, but then we're going to have another 3h. So we're going to have a total of 6h. Then we're going to have h times h, which gives us h squared. And then we still have that minus 1. And we still have that minus 8 that we got from the original blue group. All that divided by h still. Now from here we can start slashing. We have negative 1, minus 1 and minus 8. Those are going to cancel out that 9. So we're just going to be left with, I'm going to reorganize that group there. H squared plus 6h over h. And since they all have an h, we could go through and do the actual factoring out portion, but I'm just going to cancel out an h from each of those. We're going to be left with h plus 6. Now just like we did in the previous example, let's plug in h equals 0. So we'll have 0 plus 6, which gives us, well, 6. So we can say the slope at the point 3, 8 is m equals 6. Again, m for slope. Oh, I'm boxing in the wrong part. All of this is leading into our definition for a derivative. So the derivative of f at a point x is really exactly what we've been doing. So we're going to say, and this we're going to read as f prime. F prime is how we indicate that it's the derivative of function f. So f prime. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h, provided that the limit exists. Now remember that the derivative f prime is the formula for the slope of the tangent line to the point of graph f at the point f of x, or 8x comma f of x, in other words, at whatever the coordinate is at point x. So we're going to use this to find the derivative, and we're going to take a step further. So we got find the derivative of f of x equals 3x squared minus 2x. So we're going to do that same limit we just did. We're going to do the limit, oops, sorry, getting a little messy there. The limit as h approaches 0 of, sorry, I'm going to color code this again, f of x plus h minus f of x divided by h. So we got the limit as h approaches 0 of f of x plus h. So we're essentially just going to replace x with x plus h. So it was previously 3x squared minus 2x, so it's going to be 3, and then instead of x, we're going to have, sorry, my stylus is not picking up, 3 instead of x, it'll be x plus h squared minus 2 times x plus h, and then we're going to subtract just normal f of x. So we're going to subtract, sorry, let me put this in brackets here. So that's the red group, and then we're going to subtract all of f of x, which was just 3x squared minus 2x. Now we do have a little bit of work we need to clean up here. Oops, sorry, I forgot one thing. All that's still being divided by h. We are going to have to clean up that red group a little bit. So we got still the limit as h approaches 0 of 3 times, switching colors, 3 times x plus h squared. Remember, that's x plus h times x plus h. And then while we're at it, let's also distribute the 2 to the x and the h here. So we got minus 2x minus 2h because it's a negative 2. And then the other group is going to be still the minus 3x squared. And then I'm also going to distribute, so we're distributing that negative to the 3x squared and to that negative 2x. So it's actually going to end up being plus 2x. All this still being divided by good old h. Now, distributing there, we'll have x times x, so we got 3 times x squared. Then we're going to have hx and another hx, so we're going to have plus 2hx, and then plus h squared. Still have the rest of it, we can actually start canceling out some stuff. So we're going to have minus 2x plus 2x, those can cancel out, so we no longer need them. So from our red group, we're going to have minus 2h, and then from the blue group, the only thing that's left is minus that 3x squared. Now let's go ahead, getting ahead of myself again. Still all that divided by h, and again, this is the limit as h approaches 0. Now I'm running out of vertical space, so I'm going to have to shift to the right a little bit. But let's distribute that 3 to the x, to the 2hx, and to the h squared. So we got still, again, the limit as h approaches 0. And then let's distribute that red group. So we got 3x squared minus 3 times 2h, plus 3 times 2hx is going to be 6hx. And then 3 times h squared is going to be 3h squared. And then we still have that minus 2h, and finally that minus 3x squared that we had left over from good old f of x. All this divided by h. Thankfully, we're going to be able to cancel out some of this stuff. So we have 3x squared and a minus 3x squared. Those are going to cancel out. So now we're left with the limit as h approaches 0. And everything else we have here is going to be 6hx plus 3h squared minus 2h over h. Now everything has an h in it. In other words, we can simplify this by canceling out an h from each of these. So let's cancel out an h here, one of these h's, and an h here. So now we're left with 6x minus 3h minus 2. So again, this is the limit as h approaches 0. Now that's as simplified as we're going to get. Now let's plug in h equals 0. So we have 6x minus 3 times 0 minus 2. That just simplifies to be 6x minus 2. And folks, that's as far as we're going to be able to go. So we're going to say, and let me open up some space here, this is our derivative. So we're going to say f prime of x, the derivative of f of x, equals 6x minus 2. This is an equation where now we can plug in any x coordinate we want to figure out the slope at that coordinate. So if I plugged in x equals 2, I'd find out that the slope at there is positive 10. If I plugged in negative 6, I'd end up with a slope of negative 38. This is how we're going to find each of those slopes at each individual point. So again, relating it back to the original function, f of x was, the original one, was 3x squared minus 2x. I kind of want to take a look at the relationship between the numbers we see here. So kind of lining these up. In fact, maybe I'll add one little exponent here as well. That's not really easy to see on screen. Let me move it over a little bit. So we have 3x squared minus 2x, and somehow the 3x squared becomes 6x, and the 2x squared just became 2. How did we get from 3x squared to 6x? Well, what's the relationship between the 3 and the 2? Oh, okay. And then from the other one, well, that one's kind of the same relationship. 2 times 1 giving us that 2. What we're going to say, the relationship between, and I'm going to use a different color here, and we're going to analyze this more next week as well, g of x equals a times x to the m power. What's going to happen, and I'm going to add some exponents here as well. The derivative, the shortcut we're going to start using, is g of x equals, well, I'm going to take this m and multiply by the a, so it's going to be m times a, still times that x, but then our exponent is going to decrease by 1, so it's going to be m minus 1. This is going to be the shortcut for our derivatives.